In this video, I would like to introduce my project um, called Interfacing a Teleoperational System. My name is Mahmut Hüseyinov, and I am doing this project with the supervision of Dr. Helge Werdeman. To give an introduction about the teleoperations, the first master-slave teleoperation was built in 1940s by George. The prefix tele means at a distance. Thus, teleoperation naturally is operating at a distance. There are three types of robots: industrial robots, service robots, and robots with special missions. Industrial robots perform specific repetitive tasks and require very little intelligence. Service robots are the opposite of industrial robots. They perform some general tasks. And the third category where teleoperation is being applied is robots with special missions. They perform specific tasks just like industrial robots, but different from industrial robots, the tasks are generally very complex. These robots require high level of artificial intelligence and human aid to complete their tasks. And usually the human aid is given through the teleoperation system. To give some applications of the teleoperational systems, they are usually used in medical applications such as heart surgeries and any other type of surgeries, in radioactive applications where in nuclear weapon and nuclear energy stations, in firefighting applications and space applications. Usually these applications are where the humans are limited, and by the use of teleoperational systems, they can accomplish the tasks with lower risk. In terms of the related work and the challenges in this area, we can look at the problem from 2 points of view. The first one is the control point of view, and the other one is the mapping point of view. From the control point of view, the main goals of the teleoperation system are stability and the telepresence. Stability refers to the closed loop system of the control, and usually in the papers, the main addressed problem is the time delays. With the telepresence, it means providing the human operator the sense of presence in the tele environment, meaning the operator would feel and move objects as if he was in the environment, he was in the tele environment. Time delays are very important because they cause the user to adapt the move and wait strategy, and this not only increases the task complexity and completion time, but it also causes confusion and increases the mental workload. Supervisory control, two-port networks, scattering approach, passive control, sliding mode control, control over the internet communications, etc. were tried. Each has their own advantage and disadvantages. Internet control is chosen for this project because it allows flexible communication, meaning with internet communications, two different protocols can be applied, one called TCP, the other called UDP. TCP allows none of the signals to be lost, but at the cost of the time delays being higher, so it uses a buffer, whereas UDP allows the real-time signal transmission, but at the cost of some of the signals being lost. As mentioned before, mapping is the other important aspect. Mapping refers to how the motion of the master will affect the motion of the slave. So how the motion of the robot will affect the motion of the, how the motion of the operator will affect the motion of the robot. And there are also different strategies tried. There is direct joint space mapping, Cartesian mapping, direct mapping, and AI-based mapping, whereas AI-based mapping is very recent and it's still being developed. For our project, we use Cartesian mapping. The aims and objectives of this project. So in this project, we are designing a teleoperational system as a master-slave configuration, and Franka, Emika, Panda robot and Geomagic TouchX haptic device are the two main devices to design this system. The aim is to integrate the two devices through the robot operating system, ROS, and hence the human can use the TouchX device to give the position to the robot, and the robot will navigate to these positions. One other object is to integrate a pedal clutch to the system, which would allow the user to enable the robot to follow the motion of the TouchX, such that it would allow the scale of the TouchX to be different from the scale of the robot. The methods used are, basically we will use ROS as mentioned before, because it allows easy framework for integrating and programming. A node will be created for TouchX, another node will be created for the robot, and the final ROS node will be created for the pedal clutch. Raspberry Pi will be used to run this final node. The PC will connect all these devices and will be the master in the sense of ROS. So all devices will communicate through the PC. For the connections, Ethernet cable will be used instead of the wireless connections due to some reasons with some problems with the internet connection in the laboratory. Robot and TouchX ROS drivers are available on GitHub. The problem of time delays will be decreased by using torque control mode of the robot with internet communications. Cartesian mapping will be applied to allow intuitive control and scaling for the operator.